Okay, children, now we are going to start a video regarding isomerism lesson. Now, I just wanted to introduce the word isomerism. Without wasting time, we directly go to the topic, that is isomerism. So what I am going to discuss is isomerism and isomers. All right. Now, first we will discuss what is the difference between these two terms, isomerism and isomers. How is isomerism? What is isomerism is? Now, when I concern the isomerism is something like this. The word isomerism means existence of different displayed formula for the same molecular formula. Now, for an example, if I concern my molecular formula is, C5H12, I mean in alkane. Now, in this lesson, I am going to explain isomerisms of the alkane. So, this is the molecular formula of the alkane. You know that molecular formula is the formula that it shows the real number of atoms present. So, this is the C5H12. We call that is molecular formula of pentane. Now I can draw this 5 carbon atom and 12 hydrogen atom in different patterns. So each pattern becomes an isomer. Now for an example, if I concern this 1, 2, 3, 4, 5 carbon there. So this 5 carbon has 12 hydrogen connecting this way. When we are connecting this hydrogen atom, each atom need to connect it with each carbon atom need to connect it with the 4 bonds. This carbon has 4 bonds. You can clearly see that this carbon atom has 4 bonds, and this carbon atom has 4 bonds. It's compulsory case that carbon need to make 4 bonds. So this is the one isomer for the pentane. This is the one isomer for the pentane. Right. Then I can draw another isomer for the pentane. So if I consider another isomer for the pentane, if I draw another isomer for the pentane, see this one. If I draw another isomer for the pentane, 5 carbon atoms. This time I arrange this 5 carbon atom in 4 in a chain and 1 as a branch. So now you can see that this carbon has 4 bonds. This already has 3 bonds. There's only one vacancy for the hydrogen then. So then hydrogen and hydrogen. So in this way, the CH carbon has 4 bonds. So this is another isomer for the pentane. So the next one, I can draw another isomer for the pentane. 1, 2, 3, and 2 branches here. So this is another isomer for the pentane. So see this one, in this displayed formula for the isomer also contains 4 bonds for the 1 carbon atom. Now in all of these, you can see that 5 carbon atoms there, 12 hydrogen there. 5 carbon atoms there, 12 hydrogen there. 5 carbon atoms there, 12 hydrogen atoms are there. So now what is isomer is? Isomer is different displayed formula. Actually, there are 3 displayed formula. Isomer. What is isomer is? Isomer means different displayed formula for the same molecular formula called what? Isomer. I will repeat it again. Isomer means different displayed or structural formula for the same molecular formula. Different displayed or structural formula for the same molecular formula is called isomer. Now, children, there's another word we call that is isomerism. What is isomerism means? Isomerism means, now what is isomerism? Now, word isomerism means existence of isomers called isomerism. What is isomerism is existence of isomers called isomerism. I mean, existence of different displayed formula for the same molecular formula is called what? Isomerism. So these two words are little different, isomer and isomerism. Isomer means different displayed or structural formula for the same molecular formula. Isomerism means existence of different displayed or structural formula for the same molecular formula is called what? Isomerism. Now, when I concern this pentane molecule, it has three isomers like this way. Right, this pentane molecule has three isomers like this way. So this is one example I showed. Now look at here. Now just easy method. I will give you easy trick to understand whether the isomer that you drew is a correct one or wrong. It's something like this. Now if I concern here 1, 2, 3, 4, 5 carbon atoms there. Now here 1, 2, 3, 4, 5 dots are put in a zigzag pattern like. So join this 1, 2, 3, 4, 5. So this is a one isomer. This is called skeletal formula for this one, right? And now the next thing is for this thing, right? So, okay. Now in the chain, how many? 1, 2, 3, 4 there. 1, 2, 3, 4 there. So we put 4 dots. And you see the branch in from this side, the second one has a branch. We mark it like this way. And this one, 1, 2, 3 is there. 1, 2, 3 is there. So, it has 2 branches. So I mark it like this way. Now you can understand that. Now in this kind of thing, just imagine this is a 1 zigzag. 1, 2, 3, 4, 5 is there. 1, 2, 3, 4, 5 is there. So now this one, 2, 3, 4. This one is not a new isomer. It is same, right? Right. I mean, similarly, if you make a bend, 1, 2, 3, 4. Sometimes the student write like this way. They write it like this way. And they think that the upper one and this one, the upper one and this one both same. Right? These both are same. Right? Some of the students think that this is a one isomer and this is another new isomer. Remember, from the carbon skeleton, if the letter L is made, from the carbon skeleton, if the letter L is made like, see, you see the letter L is inverted. If you see the letter L, it is not a new isomer. You see that this and this is not different. Right. Similarly, so don't misunderstand. If you see the bending like this way, if you see the bending like this way, these bendings or L letters are not new isomers. Is it clear? So then this one is pentane and this one also pentane. So it is not a new branch. So you have to understand that. Right. I got another one. So see that if I take this one, if I can hold from this part and rotate it upwards, it will be like this. 1, 2, 3, 4. It appears like this manner. It appears like this manner. So this is not new isomer. This one and this one both same. So that means the rotation of this one is not new isomer. I mean, if any student write rotation of that, If any student write rotation of that, that is not a new isomer. The one I drew in up here, the one I drew in up here, and this and this both are same isomer. So see, remember this, rotations are not new isomers. So if you draw the skeleton, you can understand it is bending or you can understand it is rotation. Rotations are not new isomers. Is it clear? Now, for an example, if you see something like this way, 2, 3, 4, 5, like this way, and then if you think that is, this one is not new isomer, it is same as this thing, right? Okay, now I got another second item, second example of my lesson. Then I got that C6, C6 and H14. There is another alkane. So now you know clearly what are the alkanes are. Alkanes have the same molecular formula, but different displayed those structural formula. So I want to arrange 6 carbon atoms. 1, 2, 3, 4, 5, and 6. So I write here structural formula like this is CH3, and here it is CH2, 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 and then CH3. So this is the one isomer of hexane. You know, name of this one is hexane. This is the one isomer of hexane. Why I call this hexane? That it has 6 carbon atoms and is an alkane. So this is hexane. And the next thing is, I want to draw the isomer for the hexane. 1, 2, 3, 4, 5 in a branch. Earlier 6 in a branch. Now this time 5 in a earlier 6 in a chain. Earlier 6 in a chain. Now this time 5 in a chain and 1 branch I put. So here CH3, CH3. You can see, children, there are 1, 2, 3 bonds. So there's a 1 vacancy for hydrogen. And there are 2 bonds already present. So 2 vacancies for the hydrogen. Carbon can make maximum 4 bonds. 2 bonds are already present. So only 2 vacancies for the hydrogen. Carbon has already 1 bond. So 3 vacancies for the hydrogen. So if I draw the skeleton for this one, 1, 2, 3, 4, 5. So put 5 dots, 2, 3, 4, 5. And then the second one has a branch. So we can put it like this way. Right. If some student draw it upside, that is also the same isomer. I mean 1, 2, 3, 4, 5. If any student draw it like this way, I mean this CH3 moves up, it is the same isomer, it's not a new one. Right, so this is not a new one. That's what I want to say. Okay, anyhow, I drew 2 isomers for this one. Then I got my third isomer for the hexane. So 1, 2, 3, 4, 5 is there. There's 5 in the chain. Now earlier 1 branch, the branch was from this side, second carbon. Branch was from that side, second carbon. And now I put the branch from that side, third carbon. Chain has 5 carbon atoms, 3, 4, and 5. I put the branch to the third carbon atom. Number 1 carbon, number 2 carbon, number 3 carbon, number 4 carbon, and number 5 carbon. So I put the branch to the third carbon atom. Oh, hydrogen carbon has already 1 bond, so another 3 chances. This carbon has 2 bonds, so another 2 chances. This carbon has 1 bond, 3 chances. This carbon should have 1 hydrogen only. This carbon, 2 hydrogen, and this carbon, another 3 hydrogen. Then I can draw another isomer for this one. That is 1, 2, 3, 4 carbon atom. Here, 6 carbon atom in a chain, 5 and 1 branch. Here 5 and 1 branch in a new position, third carbon. Here 5 and 1 branch in a second carbon. Right. So here 5 and 1 branch in the third carbon. Now 6 carbon atom in a chain, 5 and a 1 branch, 5 and a 1 branch. Here 4 and 2 branches. So we put the branches to these two places. Right. We put the branches to that two place. And if it is CH3, now there are three bonds already. So one vacancy for the hydrogen, 3 bonds already, one vacancy for the hydrogen, 3 bonds already, one bond already, 3 vacancies for the hydrogen, one bond present, 3 vacancies for the hydrogen, carbon. This has one bond, 3 vacancies for the hydrogen. Right? So then I can draw another isomer. See that here 4 carbon atom and 2 branches in 2 different. So why don't I put 2 branches to the same place like this way? 2 branches to the same place. So it is CH3, this one CH3, this one CH3. See this carbon, already 4 bonds completed. This carbon can have 2 hydrogen and this one has 3 hydrogen. Like that, we can draw many number of isomers as possible. Right, so then how can I find the maximum number of isomers can be drawn? See that now I will teach you an easy trick to identify is there another isomer or not. Right. It is like this way. I will explain you easy trick to identify is there another isomer or not. That is the equation or formula that I didn't teach you in the classes, but now I explain it to you. So there is the equation 2 to the power n, 2 to the power n minus 4 plus 1. You apply for this equation, 2 to the power n, n means the number of carbon atom. Here how many carbon atom? 6. 6 minus 2 plus 1, right? Okay. 6 minus 2 means, sorry, 6 minus 4. 6 minus 4, it should be 6 minus 4. 6 minus 4 is 2. So it is one thing. 2 to the power 6 minus 2, 2 plus 1. So 2 to the power 2 is what? 4. 4 plus 1, 5. The maximum number of isomers is 5. See that? So how many maximum number of isomers? 5. So more than that I can't draw. 1, 2, 3, 4, 5 isomers I have done. So that is a maximum number of isomers I can write. So sometimes in exam, they ask you to draw the maximum possible number of isomers. They ask you to draw the maximum possible number of isomers. So at that time, you need to know what is the maximum number of isomers you can draw. Right. So it is like that. Right. So this is the maximum number of isomers you can draw. Now this is another isomer. I will go to another example. Now another thing that I want to highlight, whenever there is a branch, there's a letter T made from the carbon atoms. Letter T made from the carbon atom. See here, you see the T here, right? When there's T, that is correct isomer. You see the T here, that is correct isomer. You see T here, from the carbon atoms, you see the T. You see many T's here, right? You see many T letters here, right? So now that is the correct way of drawing branches. If you see L, it is not a new branch. It is not a new thing. Now for an example, see this one that you see in the board now. It has 1, 2, 3, 4, 5, 6. If you draw this one, CH3 dash CH2 dash, CH2 dash, CH2 1, 2, 3, 4. The fifth one here, CH2. If you put it down, this is not a new isomer. It is same as above. As you can see that letter L is not a new isomer. You see the letter L here. L is not a new isomer. So that is what the isomer is. Now, so then, now this is, I will give you easy trick to find how many isomers can be made from the given thing. That is from 3 carbon atoms. From 3 carbon atoms to 7 carbon atoms. Now, for an example, say that if I have 1 carbon atom alkane, 1 carbon atom alkane, only this isomer, only one isomer can be drawn. If I go to 2 carbon atom alkane, right? If I go to 2 carbon atom alkane, what the maximum number of isomers can be drawn? Only one. No more changes can be made. If there is 3 carbon atom isomers, if there's a 3 carbon atom alkane, the maximum number of isomers can be drawn is only one. Because 2 and branch is cannot be drawable for this. But if I try it, 1, 2 and branch, you see the letter L. See that? You see from the carbon atoms, you see the letter L. So this is not a new isomer. So this is not a new isomer. So when 1 carbon there, only one isomer. When 2 carbons there, only one isomer. When 3 carbon there, only one isomer. The isomers are increasing more than one when there are 4 carbon atoms or more than that, right? Okay. Now, when there are 4 carbon atoms, when N is equal 4, when there are 4 carbon atoms, what is our equation is number of isomers equal 2 to the power N minus 4 plus 1. Is it clear? So then 2 to the power 4 minus 4 plus 1. So here 2 to the power 1 plus 1 is equal to, 2 to the power 0 plus 1 is equal 1. 2 to the power 0 means 1. Any number 0th index is 1. You know that in maths. 1 plus 1 is equal to. So the maximum number of isomers can be drawn is 2. So we see that, right? We see that when there are 4 carbon atoms, when there are 4 carbon atoms, it will be like this way. When there are 4 carbon atoms, the isomer is like this way. 4 carbon atoms. Alright. Now I can try 3 in a chain, 1 branch. But I can't do it this way. The letter L. No, it is wrong. Right. If I complete that, see, this is wrong. Why? From the carbon atoms, its letter L make that is bending. It is not a new isomer. You can experience that when you draw the skeletal formula like this way. 1, 2, 3, 4. 1, 2, 3. If you bend it like this way, the same thing is there. So like that. But if you put a branch, branches are put in a way that letter T is made. See that. Letter T is made from the carbon atoms only. See that. The letter T is made from the carbon atoms. This way the T is there. And then see that this is our new isomer. So then, as I said that when the number of carbon atom is 4, isomers 2. How comes? C to the power, sorry, n 2 to the power n, 2 to the power n minus 4 plus 1. 2 to the power 4 is the carbon number, 4 minus 4 plus 1. 2 to the power 0 plus 1. Here the value is 2 to the power 0 equals 1. 1 plus 1 is equal to. right? Any numbers to the power 0 is equal to 1. Right. Then I go to this one. As I did earlier, the 5 carbon atom example, I did it. So then how many isomers? 2 to the power n minus 4 plus 1. 2 to the power 5 minus 4 plus 1. 2 to the power, so here 1 plus 1, the answer is 3. So when the pentane is there are 3 isomers, I told you earlier. The pentane 1, 2, 3, 4, 5. So this is one isomer, right? 1, 2, 3, 4. And this is another isomer. And 1, 2, 3, and 2 branches. So this is the other isomer. So these are the isomers for C5H12 is molecular formula. Those are the same molecular formula and different displayed formula. They are the isomers, right? So then I just wanted to explain you what is the difference between isomer and isomerism. Isomer is different displayed formula for the same molecular formula. Isomerism means existence of different displayed formula for the same molecular formula. I want to show you the easy method. How do we identify maximum number of isomers possible? Sometimes there's maximum 5, but students try to draw the 6th one, so they waste time in the exam. That is why I wanted to do this video. Okay, then, thank you very much.